Let me show a video explaining the basic concept of permutation and combination. To start this lecture, this is one subject I would like to start. That is arrangement. The number of arranging a character A is only 1. Then how about arranging the two characters A and B? From the arrangement of one character A, the character B can be placed onto the left or right of A. So there will be two cases. How about three characters A, B, and C? From each of the arrangement of two characters A and B, C can be placed onto the left, middle, or right. So there will be 6 cases in total, multiplying 3 from the previous case. Then how about 4 characters A, B, C, and D? From each of the previous arrangements of 3 characters, D can be placed in 4 places. Then there will be 24 cases in total, multiplying 4 from the previous case. So you can easily see that the number of arranging n distinct elements is the multiplication from 1 to n, which is n factorial. Let me show you another way to approach the arrangement. The more you know about the various approaches, the more confident you'll be about this topic. For this explanation, let me bring the example of arranging 4 characters A, B, C, and D. Suppose that you arrange these 4 characters onto these 4 blue boxes. Then onto the first box, you have the option to choose one of these 4. After you choose one, you can choose one of the rest 3 onto the second box. Onto the third box, you have an option of 2. At the last box, you will choose the remaining one. By multiplying all of these numbers, you will realize that there are 24 cases of arranging 4 characters. This method is a well-known method in understanding the concept of arrangement. Now let's move on to the permutation. While arrangement explains how to count the number of cases arranging the elements, permutation shows the way of counting the number of choosing and then arranging a specific number of elements. Let me show how many cases there are when choosing and arranging 3 balls from 5 different balls. Suppose that you arrange the chosen 3 balls in this row. In the first row, you can choose any of these 5 different balls. Once you choose a ball, you can choose one of the rest 4 balls in the second row, and then you can choose one of the rest 3 balls in the last row. As you've seen, you have 5 options for the first row, 4 options for the second row, and 3 options for the last row. Then multiplying these, you get 60, the answer of this problem. Likewise, from n distinct elements, the number of selecting r and arranging them equals the multiplication from n to n minus r plus 1. This formula can be defined as n permute r, meaning the number permuting r from n objects. And this is exactly equals to n factorial divided by n minus r factorial. To give you a tip, if you do not understand this concept, drawing and counting on your own is a good way to understand. It looks very time-consuming and boring, but frankly, counting on your own could be a very nice beginning for challenging this chapter. I am just telling you based on my experience. The next is the combination. While the permutation is choosing and then arranging, the combination is counting only the way to choose and does not consider the arrangement. This problem is an example of the combination. Let's count the number of choosing 2 from the following 5 colors. As I suggested previously, let me directly count the cases. I can choose red and yellow, and I can choose red and green. By counting all cases, I get 10 cases. This is defined as 5 choose 2, meaning the number of choosing 2 from 5 objects. It has the following formula, and by calculating it, it returns 10. Likewise, the number of choosing R objects from n distinct elements is equal to n choose R, which is also equal to n factorial divided by R factorial times n minus R factorial. In some other math books, n choose R is also denoted by this. Again, let's go back to the previous example and picture. Let me hide the colors and just focus on this part. What does it look like? Doesn't it look like the cases of arrangement of 2 O's and 3 X's? Exactly. So the number of choosing 2 objects from 5 elements is exactly equal to the number of arranging 2 O's and 3 X's. And if I switch all O's to X's and X's to O's, it will become the number of arranging 3 O's and 2 X's. And by applying this to choosing colors, we can say that it is equal to choosing 3 colors from 5 distinct colors. So all these cases are the same, and 5 choose 2 is equal to 5 choose 3. By understanding this concept, you will be able to understand that n choose R is equal to n choose n minus R. Of course, this can easily be explained by the formula as well. Let me explain the relationship between the permutation and combination. Permutation means the number of arranging R objects from n different elements. In other words, it means the number selecting R from n distinct elements and then arranging. So it is equal to the number selecting R from n times arranging R. At this point, this part is equal to n permute R, this part is equal to n choose R, and this part is R factorial. That is, n permute R is equal to n choose R times R factorial. This can also be proven in the formula like this. Please hit like if you like my video today, and subscribe if you want to study more about math with me. Thank you for watching, and I will see you on the next video.